Hello, eighth graders. This week we will learn intercepts of a graph. We will start by setting up our objectives. The first one is to analyze graphs or tables to identify intercepts of functions. Our second objective is to solve equations by graphing. The I can statement is, I can identify intercepts of functions and solve equations by graphing. The first vocabulary word that we must learn and understand is x-intercept. The x-coordinate of a point is where a line, curve, or surface intersects the x-axis. Let's remember from when we first started to use the coordinate system, the x-axis is the horizontal line on this coordinate plane. The y-intercept is the point in which a line or curve crosses the x-axis of a graph. And then let's remember once again that the y-axis is the line that crosses the graph vertically or from top to bottom. So the intercept of a graph or point in which the graph crosses the axis, like I mentioned earlier. The x-intercept is the point at which the graph crosses the x-axis. So we see it here. The x-intercept in this example is 5. While the y-intercept is where the point crosses the y-axis. So the y-intercept in this example is 1. At this point, the x-coordinate is 0. Then we have positive and negative functions. So the positive regions of a function are those intervals where the function is above the x-axis. It is where the y values are all positive. Then the negative regions of a function are those intervals where the function is below the x-axis. It is where the y values are negative but not 0. The solution of an equation is called a root. It is any value that makes the equation true. Then 0 is an x-intercept of the graph of a function. So if we look down here, or if we take these as examples, we have that the root of the equation 3x equals 6 is 2. A linear function, like this one, has no more than one root, while a nonlinear function, like this other one down here, may have more than one.